Which of the following parameters in sklearn's decision tree classifier controls the maximum depth of the tree? A. Max depth. B. Min sample split. C. Min sample sleeve. D. All of the above. Font color blue mix depth font directly limits the maximum depth of the tree. True. Font color blue min sample split font determines the minimum number of samples required to split an internal node. A higher value may lead to shallower trees. True. Font color blue min sample sleeve font sets the minimum number of samples required to be at a leaf node. A higher value can also result in shallower trees. True. All the mentioned parameters influence the tree's depth and complexity. True. D. All of the above. Decision tree algorithm. A supervised learning method that creates a tree-like structure to predict a target variable. Gini impurity. A metric used to measure the homogeneity of a node in a decision tree. Entropy. Another metric used to measure the impurity or randomness in a node. Information gain. The decrease in entropy after splitting a node. Overfitting. When a model learns the training data too well, leading to poor performance on unseen data. Pruning. A technique used to simplify a decision tree by removing nodes to prevent overfitting. Decision boundary. The line or surface that separates different classes in a decision tree. Sklearn. A popular machine learning library in Python that provides implementations of various algorithms, including decision tree classifier. Cross-validation. A technique used to evaluate a model's performance on unseen data by splitting the dataset into multiple folds. Hyperparameter tuning. The process of finding the best values for the parameters of a model. Grid search. A method used to find the best hyperparameters by trying out all possible combinations within a specified range. Random forest. An ensemble method that combines multiple decision trees to improve prediction accuracy. Boosting. Another ensemble technique that sequentially combines weak learners to create a strong learner. Bagging. A technique that uses bootstrap aggregation to create multiple decision trees and then combine their predictions. Feature importance. A metric that indicates the importance of each input feature in a decision tree. Credit risk assessment. Predicting the probability of loan defaults based on customer data. Customer churn prediction. Identifying customers likely to switch to competitors. Medical diagnosis. Classifying diseases based on patient symptoms and test results. Image recognition. Categorizing images into different classes, example animals, objects. Fraud detection. Identifying fraudulent transactions in financial systems. Let's consider a dataset with 100 customers and their loan default status yes/no. Well, use a decision tree classifier to predict the probability of loan default. By setting max depth 3, we limit the tree to a maximum of 3 levels, preventing overfitting. Min sample split 10 ensures that a node is split only if there are at least 10 samples in it. Finally, min sample sleeve 5 mandates at least 5 samples in each leaf node. These parameters control the complexity of the tree and balance bias and variance.
Which of the following are essential parameters for the decision tree classifier in scikit-learn? A. Criterion, splitter, max depth, min-samples leaf. B. Max features, min-samples split, random state, max leaf nodes. C. All of the above. D. None of the above. A. Criterion, splitter, max depth, min-samples leaf. False. These are important parameters but not all of them. Missing parameters like max features, min-samples split, random state, max leaf nodes. B. Max features, min-samples split, random state, max leaf nodes. False. These are important parameters but not all of them. Missing parameters like criterion, splitter, max depth, min-samples leaf. C. All of the above. True. All these parameters are essential for decision tree classifier in scikit-learn. D. None of the above. False. All the parameters mentioned in A and B are essential for decision tree classifier in scikit-learn. C. All of the above. LT font style font size 14px GT LTB GT criterion LTB GT LT font GT LTB RGT LT font style font size 12px defines the function to measure the quality of a split. Common options are Gini impurity and entropy information gain. LT font GT. Customer segmentation using Gini to segment customers based on their purchasing habits. Fraud detection using entropy to identify unusual transaction patterns. 25. 5000. Yes. 30. 6000. No. 35. 700. Yes. 40. 800. No. 0.5. 1. LT font style font size 14px GT LTB GT splitter LTB GT LT font GT LTB RGT LT font style font size 12px determines the strategy used to split the data at each node. Options include best finds the best split and randomly selects a split. LT font GT. Loan risk assessment using best to find the most accurate splits based on borrower characteristics. Medical diagnosis using random to explore different split possibilities for a more robust diagnosis. LT font style font size 14px GT LTB GT max depth LTB GT LT font GT LTB RGT LT font style font size 12px maximum depth of the tree. Controls the complexity of the model. Prevents overfitting by limiting the tree's growth. LT font GT. Image classification using max depth to limit the tree's complexity and prevent overfitting on a large dataset of images. Natural language processing using max depth to control the depth of the tree when analyzing text. Data to avoid overfitting on the training data. LT font style font size 14px GT LTB GT mins amples leaf LTB GT LT font GT LTB RGT LT font style font size 12px minimum number of samples required to be at a leaf node. Ensures that leaf nodes have a sufficient number of samples for reliable predictions. LT font GT. Customer segmentation using min-samples leaf to ensure each customer segment has a sufficient number of customers for meaningful analysis. Fraud detection using min-samples leaf to prevent the model from creating too many specific rules. based on limited fraudulent transactions. LT font style quote font size 14px quote GT LTB GTMAX features LTB GT LT font GT LTB RGT LT font style quote font size 12px quote G. Number of features to consider when looking for the best split can be an integer, a fraction, or auto. Controls the complexity of the tree and can be useful for handling high-dimensional data. LT font GT. Image classification using max features to reduce the number of features considered for each split, especially when dealing with high-dimensional image data. Natural language processing using max features to select a subset of relevant features from a large set of words and phrases when analyzing text data. LT font style quote font size 14px quote GT LTB GTM INS ample split LTB GT LT font GT LTB RGT LT font style quote font size 12px quotient minimum number of samples required to split an internal node. Controls the tree's size and prevents overfitting by avoiding splits on very small groups of samples. LT font GT. Loan risk assessment using minsample split to ensure that splits are made on a sufficient number of borrowers to create robust rules. Medical diagnosis using minsample split to avoid creating overly specific rules based on limited patient data. LT font style quote font size 14px quote GT LTBG random statelt BGT LT font TGT LT BGT LT font style quote font size 12px quote GT controls the randomness in the tree building process. Can be an integer, a random state instance, or none. Ensures reproducibility and avoids model variations due to random splits. LT font GT. Image classification setting random state to ensure the same model is created each time, especially when training on a large and potentially variable image dataset. Natural language processing using random state to ensure consistent results when training a model on text data, particularly if the dataset is large or contains variations in text. LT font style quote font size 14px quote GT LTB GTM AX leaf nodes LTB GT LT font GT LTB RGT LT font style quote font size 12px quotient maximum number of leaf nodes in the tree. Limits the tree's size and can help to prevent overfitting. Used in conjunction with max depth to control the tree's complexity. LT font GT. Customer segmentation using max leaf nodes to control the number of segments created and avoid overfitting on a limited customer dataset. Fraud detection using max leaf nodes to prevent the model from becoming overly complex and creating too many specific rules for identifying fraudulent transactions. Which of the following parameters control the complexity of a decision tree in sklearns? Decision tree regressor. A. Max depth. B. Minsample split. C. Minsample's leaf. D. All of the above. A. Max depth. The max depth parameter directly controls the maximum depth of the tree. A shallower tree is less complex than a deeper tree, as it has fewer decision nodes and paths. Hence, max depth influences the complexity. True. B. Minsample split. The minsample split parameter sets the minimum number of samples required to split a node. A higher value means a split will only happen if there are enough samples, leading to fewer splits and a less complex tree. Hence, Min-sample split influences complexity. True. C. Min-sample's leaf. The min-sample's leaf parameter determines the minimum number of samples required in a leaf node. Increasing this value prevents the tree from creating very small leaf nodes, thereby limiting the tree's complexity. True. D. All of the above. All the parameters mentioned max depth. Min-sample's split. Min-sample's leaf directly or indirectly affect the complexity of the decision tree by controlling a tree's size, depth, and the number of splits. True. D. All of the above. Decision tree regressor. Decision tree regressor is an algorithm in scikit-learn sklearn for regression tasks. It constructs a decision tree to predict a continuous target variable based on input features. Let's say we want to predict house prices based on size and location. Size square featuring location price USD 1500 city 500,000, 2000 suburb 400,000, 1800 city 600,000, 1200 suburb 350,000. A decision tree regressor can be trained on this data to learn a decision tree structure that predicts house prices based on size and location. For example, the tree might split on size first if size 1800, then predict higher price otherwise, predict lower price, and then further split on location within each size range. By analyzing the data, the model creates a set of rules based on size and location to estimate house prices. Similar to how humans might make decisions based on these factors. Decision trees. Regression. Max depth. Max depth controls the maximum allowed depth of the tree. It prevents the tree from growing too deep and overfitting the training data. A shallow tree with fewer levels is less complex and easier to interpret. Let's say max depth 3. This means the deepest path in the tree can have a maximum of 3 nodes including the root. If the tree tries to grow beyond 3 levels, it will be pruned at that depth, limiting its complexity and preventing it from learning too specific patterns from the training data. A lower max depth helps the model generalize better to new data, reducing the risk of overfitting and improving its ability to make accurate predictions. Overfitting. Min-sample split. Min-sample split determines the minimum number of samples required to split an internal node. It ensures that splits are made only when there is enough data, reducing the risk of creating splits based on noisy or irrelevant patterns. Let's say min-sample split 10. A node will only split if it has at least 10 samples. This helps prevent the creation of very small, unreliable branches in the tree. If a node has fewer than 10 samples, it will not be split, effectively simplifying the tree. This prevents the tree from becoming too complex and reduces the risk of overfitting, allowing the model to make more robust predictions on unseen data. Overfitting. Min-sample's leaf. Min-sample's leaf controls the minimum number of samples required to be at a leaf node. It ensures that leaf nodes have a reasonable number of samples, preventing the creation of small, unstable leaves. Let's say min-sample's leaf 5. This means each leaf node must have at least 5 samples. If a node has fewer than 5 samples, it will be merged with its parent or another node, reducing the complexity of the tree and making it more robust. Overfitting. Which of the following is not a characteristic of the extra trees classifier in scikit-learn? A. It builds multiple decision trees, each trained on a random subset of features. B. It uses random thresholds for splitting nodes, leading to a more robust model. C. It performs feature selection to determine the most important features. D. It averages the predictions of all individual trees to make the final prediction. Correct. This is a core principle of extra trees classifier. It utilizes multiple decision trees, with each tree being trained on a random subset of features, to make predictions. Correct. This statement is true. Extra trees classifier uses random thresholds during node splitting, contributing to its robustness and reducing the risk of overfitting to specific data patterns. Incorrect. This is the incorrect choice. While extra trees classifier implicitly evaluates feature importance by observing feature selection frequency, it doesn't explicitly perform feature selection like some other tree-based models. The answer is based on this point. A metric that quantifies the contribution of each feature to a model's prediction accuracy. In a customer churn prediction model, feature importance might indicate that customer tenure is a more significant factor than age in determining churn likelihood. Correct. This is a typical ensemble approach. Extra trees classifier combines the predictions of its individual trees to arrive at a final prediction, often by averaging. C. It performs feature selection to determine the most important features. A hierarchical data structure used for classification or regression. It partitions data based on feature values to reach a final decision or prediction. A decision tree used for loan approval might consider factors like income, credit score, and loan amount to decide whether to approve or reject a loan application. A technique that combines multiple machine learning models to improve performance. The goal is to leverage the strengths of different models and reduce the risk of overfitting. A type of ensemble learning where multiple models are trained on different random subsets of original training data. In a credit risk assessment scenario, bagging can be used to train multiple decision trees, each using a different set of customer data, to improve the model's predictive accuracy. An ensemble of decision trees where each tree is trained on a random subset of both data samples and features. A random forest model used for image classification could utilize multiple decision trees trained on different parts of the image and different image features to achieve high classification accuracy. A technique where each model in an ensemble is trained on a random subset of features. A powerful ensemble classification method that utilizes multiple decision trees with randomness in both data sampling and feature selection. This leads to a robust and often highly accurate model. Which of the following statements accurately describes the key concept behind extra trees regressor? A. It constructs multiple decision trees with random feature and data subsets, averaging their predictions. B. It employs a single, highly complex decision tree, maximizing node splits for accurate predictions. C. It combines predictions from multiple linear regression models, each trained on a different data subset. D. All of the above. Correct. This statement accurately describes the core principle of extra trees regressor. It builds an ensemble of multiple decision trees, each trained on a random subset of features and data points, and averages their individual predictions to make a final prediction. This randomness helps to reduce variance and improve the model's robustness. Extra trees regressor is an ensemble learning method that leverages the power of multiple decision trees to make robust predictions. It distinguishes itself from other decision tree-based methods by introducing randomness into the tree construction process. This randomness is achieved through 1. Random subset of features. 2. Random subset of data points. This randomness helps prevent overfitting, making the model more robust to noise and variations in the data. Incorrect extra trees regressor does not use a single complex decision tree. Instead, it builds multiple decision trees and combines their predictions. It constructs multiple decision trees with random feature and data subsets, averaging their predictions. Incorrect extra trees regressor does not combine predictions from multiple linear regression models. It utilizes an ensemble of decision trees. It constructs multiple decision trees with random feature and data subsets, averaging their predictions. Incorrect. Only option A is correct. Extra trees regressor relies on decision trees, not linear regression models. It constructs multiple decision trees with random feature and data subsets, averaging their predictions. A. It constructs multiple decision trees with random feature and data subsets, averaging their predictions. Ensemble learning is a powerful machine learning technique where multiple models, often of the same type, are combined to improve overall prediction accuracy and robustness. By combining the strengths of individual models, ensembles can overcome the limitations of single models and achieve better generalization. Performance. Many real-world applications benefit from ensemble learning. For example, in fraud detection, combining multiple models can identify complex patterns and reduce false positives negatives. Similarly, in medical diagnosis, ensemble models can improve accuracy by considering different perspectives and reducing the risk of misdiagnosis. Decision trees are tree-like structures used in machine learning for both classification and regression tasks. They partition the data based on decision rules, leading to a prediction at the leaf nodes. Each internal node represents a feature, and each branch represents a decision rule based on the value of that feature. Decision trees are easy to understand and interpret, making them popular for decision-making processes. Decision trees are widely used in various fields, including finance, healthcare, and marketing. For instance, in financial risk assessment, decision trees can help predict loan defaults based on borrower characteristics. In healthcare, they can assist in diagnosing diseases by analyzing patient symptoms and medical history. In marketing, decision trees can identify customer segments with higher purchase probabilities. Introducing randomness into the tree building process in extra trees regressor is crucial for preventing overfitting and creating more diverse trees. This randomness is achieved by randomly selecting features and data points for each tree. By building trees on different subsets of data and features, the ensemble becomes less dependent on specific data points or features, leading to improved robustness and generalization. The randomness in tree construction helps extra trees regressor handle noisy or complex datasets. In image classification, for instance, random feature selection can help capture different visual patterns within images, leading to better classification accuracy. In financial forecasting, the random data sampling can help mitigate the impact of outliers or sudden market fluctuations, producing more stable predictions. The final prediction in extra trees regressor is obtained by averaging the predictions of all A individual trees in the ensemble. This averaging process reduces variance and improves the overall prediction stability. The averaging mechanism helps to smooth out the individual predictions and reduce the impact of noise or outliers. The averaging approach is particularly useful when dealing with complex or noisy datasets. In stock market forecasting, averaging predictions from multiple trees can help mitigate the influence of individual stock price fluctuations, leading to more reliable market predictions. In sentiment analysis, averaging predictions from trees trained on different text snippets can help capture the overall sentiment of a large corpus of text. What is the purpose of the export graph viz function in scikit-learn sklearn? A. To train a decision tree model. B. To evaluate the performance of a decision tree model. C. To visualize a decision tree model as a graph. D. To convert a decision tree model into a different format. False. The export graph viz function does not train a decision tree model. Training a decision tree model is typically done using the decision tree classifier or decision tree regressor classes in scikit-learn. The export graph viz function in scikit-learn is designed to create a dot file representation of a trained decision tree model. This dot file can then be rendered using graph visualization tools like GraphViz to produce a visual representation of the tree structure. False. Evaluating the performance of a decision tree model typically involves metrics like accuracy, precision, recall, F1 score, and area under the ROC curve AUC. The export graph viz function is not directly used for performance evaluation. The export graph viz function in scikit-learn is designed to create a dot file representation of a trained decision tree model. This dot file can then be rendered using graph visualization tools like GraphViz to produce a visual representation of the tree structure. True. The export graph viz function is primarily used to generate a dot file, which is a text-based format used to represent graph structures. This dot file can then be rendered using graph visualization tools like GraphViz to create a visual representation of the decision tree. The export graph viz function in scikit-learn is designed to create a dot file representation of a trained decision tree model. This dot file can then be rendered using graph visualization tools like GraphViz to produce a visual representation of the tree structure. False. While the export graph viz function does generate a dot file a different format, its primary goal is visualization, not general model format conversion. The export graph viz function in scikit-learn is designed to create a dot file representation of a trained decision tree model. This dot file can then be rendered using graph visualization tools like GraphViz to produce a visual representation of the tree structure. C. To visualize a decision tree model as a graph. Decision trees. Decision trees are a type of supervised learning algorithm that partition data into subsets based on features, predicting customer churn based on demographics, purchase history, and engagement metrics. Dot-directed acyclic graph file. A dot file is a text-based format used to describe graph structures, representing a complex network of relationships in social media analysis. GraphViz, a software suite for visualizing graphs. It reads dot files and generates images, e.g., PNG, SVG. Creating flowcharts for software development processes. From sklearn, tree import decision tree classifier. Export graph viz. From sklearn, datasets import load iris. From graphviz import source. Import pandas as PD. Iris load iris. X iris. Data. Y iris. Target. DT decision tree classifier random state 42. DT. Fitix. Y. Dot data export graph viz dt. Out file none. Feature name Cyrus. Feature names. Class name Cyrus. Target names. Filled true. Rounded true. Special characters true. Graph sorted data. Graph. Let's say we're building a decision tree model to predict whether a customer will buy a product based on their age and income. Age years income USD purchase. Dash 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 dash. 25500 yes. 30600 yes. 35700 no. 40800 no. The decision tree might split the data based on age first, then income, and finally predict purchase based on the final leaf node. The export graph viz function would create a dot file representing this tree structure. GraphViz could then visualize this tree, showing the branches and nodes. You have trained a decision tree model using scikit-learn. How would you visualize the tree structure in a human-readable format using text representation? A. Tree, plot tree model. Tree, plot tree. This function is used to visualize the decision tree graphically, not as text. False. B. Model, print tree. Model, print tree. Scikit-learn doesn't provide a print tree method directly for decision tree models. False. C. Tree, export text model, feature names features. Tree, export text. This function generates a textual representation of the decision tree, making it easy to understand and interpret. The feature names argument allows you to provide a list of feature names for clearer visualization. True. D. All of the above. All of the above. Since options A and B are incorrect, this option is also incorrect. False. Decision tree model. A decision tree model is a supervised learning algorithm used for both classification and regression tasks. It partitions the data into subsets based on feature values, creating a tree-like structure where each node represents a decision based on a feature, and each leaf node represents a prediction. Predicting customer churn in a telecom company based on factors like calling duration, data usage, and plan type. Classifying email messages as spam or not spam based on words present in the email content. Predicting house prices based on features like location, size, and number of bedrooms. Consider a dataset of customer data with features like age, income, and purchase history, and a target variable churn indicating whether a customer has churned or not. We can train a decision tree model on this data to predict customer churn. sklearn, tree, decision tree classifier. This class in scikit-learn is used for building decision tree models for classification tasks. Classifying images as cat or dog based on pixel values. A decision tree classifier can be used to classify handwritten digits based on pixel intensity. Values. sklearn, tree, decision tree regressor. This class in scikit-learn is used for building decision tree models for regression tasks. Predicting stock prices based on historical stock data. A decision tree regressor can be used to predict the price of a house based on its size, location, and number of bedrooms. Tree visualization. Visualizing decision trees can help in understanding how the model makes predictions. It allows for easy analysis of the model's decision-making process, identifying the key features influencing the model's predictions. Debugging the model by checking for unexpected or incorrect decision paths. Communicating the model's behavior to stakeholders. Visualizing a decision tree for predicting customer churn can reveal that customers with high call duration and low data usage are more likely to churn. 3. Plot tree. This function in scikit-learn provides a graphical visualization of the decision tree. Visualizing the decision tree in a user-friendly format. The plot tree function can be used to create a graphical representation of the decision tree used to classify handwritten digits. Tree. Export graph viz. This function generates a dot file that can be used to create a graph visualization of the decision tree using tools like GraphViz. Creating a more detailed and customizable visualization of the decision tree. The export GraphViz function can be used to create a dot file representing the decision tree used to predict house prices. Tree. Export text. This function provides a textual representation of the decision tree, creating a human-readable representation of the decision tree. The export text function can be used to create a text-based visualization of the decision tree used to classify email messages as spam or not spam. Feature names. The feature names argument in tree. Export text allows you to provide a list of feature names that will be used to label the nodes in the textual representation of the decision tree, ensuring that the textual representation of the decision tree is clear and understandable. When exporting the decision tree for predicting customer churn, providing feature names like age, income, and purchase history makes the output more interpretable. Model interpretation. Visualizing a decision tree can help to understand the model's decision-making process and identify the most important features influencing the predictions. Gaining insights into the model's behavior. By analyzing the textual representation of a decision tree for predicting house prices, we can understand which features are most influential in determining price. Model debugging. Visualizing the decision tree can help to identify errors or unexpected decision paths in the model. Enabling debugging. Identifying and correcting errors in the model. If a decision tree for classifying handwritten digits makes incorrect predictions, visualizing the tree can help identify the nodes responsible for the errors. Model documentation. Visualizing the decision tree can be used to create clear documentation of the model structure and decision logic, communicating the model's behavior to stakeholders. The textual representation of a decision tree for predicting customer churn can be included in a model's documentation for reference. C. Tree. Export text model. Feature names features. What are the main functionalities of the plot tree function in sklearn? Tree. Visualize a trained decision tree model. Display the tree's structure and node information. Provide insights into the decision-making process of the tree. All of the above. A. Visualize a trained decision tree model. True. The plot tree function in sklearn tree is specifically designed to visualize the trained decision tree model. It creates a graphical representation of the tree structure, making it easier to understand the model's decision-making process. B. Display the tree's structure and node information. True. The generated visualization shows the tree structure, including the node's internal and leaf nodes, branches, and the decision rules associated with each node. This provides a visual representation of the tree's organization and how it classifies or predicts data. C. Provide insights into the decision-making process of the tree. True. By visualizing the tree, you can gain insights into how the model makes predictions. Each node in the tree represents a decision based on a specific feature, and the paths through the tree represent the decision-making process for different data instances. D. All of the above. True. The plottree function in sklearn tree combines all these functionalities. It visualizes the trained decision tree model, displaying its structure and node information, thereby providing insights into the decision-making process. All of the above. Decision tree visualization. The plottree function is a powerful tool for visualizing decision trees. It helps to understand the structure of the tree, the decision rules applied at each node, and the overall decision-making process. Model analysis. Visualize a trained decision tree model and examine its structure. Model interpretation. Understand how the model makes predictions based on the decision rules. Feature selection. Identify the most important features used by the tree. Debugging. Visualize the tree to identify potential errors or inconsistencies. sklearn tree plottree. A function in the sklearn tree module that visualizes a trained decision tree model using matplotlib. Visualizing a trained decision tree model for analysis and interpretation. Decision tree classifier. A class in scikit-learn that implements the decision tree algorithm for classification tasks. Building decision tree models for classification problems such as predicting customer churn, detecting fraud, or classifying images. Decision tree model. A supervised learning model that uses a tree-like structure to represent decisions and their consequences. Predicting categorical outcomes based on input features. Feature importance. A measure of how important each feature is in the decision-making process of a decision tree. Identifying the most influential features for model performance. Plot tree decision tree model. The syntax for using the plot tree function, where decision tree model is a trained decision tree model. Generating a visual representation of a trained decision tree model. Related concepts. Other concepts closely related to decision tree visualization and model building. Decision tree regressor. A class in scikit-learn that implements the decision tree algorithm for regression tasks. Building decision tree models for regression problems such as predicting house prices, stock prices, or customer spending. Export GraphViz. A function in scikit-learn that allows you to export a decision tree model to GraphViz format. Generating a GraphViz representation of a decision tree model for further customization or visualization. GraphViz. A graph visualization software that can be used to render decision tree models. Rendering decision tree models in various formats, including PDF, SVG, and PNG. Feature importances. An attribute of a trained decision tree model that provides the importance of each feature in a model. Determining the relative importance of features for making predictions. Criterion. a parameter in the decision tree classifier and decision tree regressor classes that specifies a function to measure the quality of a split. Selecting a suitable criterion for splitting nodes in the decision tree, such as Gini or entropy for classification and MSE or ME for regression. Max depth, a parameter in the decision tree classifier and decision tree regressor classes that limits the maximum depth of the decision tree. Controlling the complexity of the decision tree to prevent overfitting. Min-sample split, a parameter in the decision tree classifier and decision tree regressor classes that specifies a minimum number of samples required to split an internal node, preventing the decision tree from splitting on nodes with too few samples. Min-samples leaf, a parameter in the decision tree classifier and decision tree regressor classes that specifies a minimum number of samples required to be at a leaf node, ensuring that leaf nodes have a sufficient number of samples for reliable predictions. Max features, a parameter in the decision tree classifier and decision tree regressor classes that specifies a maximum number of features to consider when splitting a node, reducing the number of features considered at each split to improve efficiency and potentially reduce overfitting. Splitter, a parameter in the decision tree classifier and decision tree regressor classes that specifies a strategy used to split nodes. Choosing between best selects the best split based on the criterion and randomly selects a split from a subset of features splitting strategies. Random state, a parameter in the decision tree classifier and decision tree regressor classes that controls a randomness in the tree construction process, setting a specific random seed to ensure reproducibility of the model results.